By the time students get to their third year of the physics major, they really know an extraordinary amount of physics. And that is really a secondary goal of what we're teaching here. Junior Lab is really about the professional development of the student as a scientist, and that means things like approaching a difficult piece of apparatus with an attitude that you're going to be able to get it done. Understanding that anything you try is not going to work the first time, you're going to have to debug it. It's about keeping very careful records of what you've done so that when you have to go back and repeat it, you can see what you've done. There's a large number of things that sort of add up to this is the way a professional does it, which is different than almost anything they've done previously in their career as a physics student.
So our class, the CIM classes, the goal is to get students to learn to communicate like professional practitioners of their own disciplines. And that is really what 813, I think, excels at, getting students to work and think and talk and write like physicists. Students have to present over and over and over again throughout the course of the semester. And we think that this iterative process is really important. You know, we start out giving them some instruction at the beginning of the semester, but often they still don't feel wholly comfortable with what they're doing the first time they present. And so once they've presented, they get videotaped. And then we meet with them to discuss the video, to discuss the slides, to see what worked and what didn't work. And those one-on-one conferences that we have with them, you know, they're reinforcing the core concepts in the instruction, but in a way that's really directly linked to the work that they've already done, the work that they're continuing to do, and to challenges that they've already experienced, so they can really understand sort of the significance of these strategies.
Your primary mode in the laboratory should really be as a coach. You're trying to figure out what that student needs at that moment in time. There's a phrase here that's sometimes called just-in-time teaching. And if you know what that means, it's something where the laboratory is sort of the perfect place to do that type of teaching. Oftentimes the tasks we give students in the lab are really complex. They may not have all the background. They may not have all the background they need in order to complete the task, but when they're starting it. That level of uncertainty really causes some anxiety in the students and can be a barrier to their learning. But if you're a professional scientist, this type of anxiety is something you're actually very familiar with. Most of us really don't know what we're doing when we start a new research project. I find it very useful to notice when a student is in that condition and call it out and actually explain how this is actually a very normal thing. This is not them being in a state of failure. This is them actually feeling like what a real scientist feels like. A major part of a course like this is building up the student's identity as a scientist, helping them move their understanding of themselves from being a physics student to being a physicist. If we can achieve that by the end of the semester, then this course is a complete success, even if they learned not a single thing about quantum mechanics or relativity.
What makes 813 or Junior Lab unique to me as a teacher is that I am able to actually do coaching in that class as opposed to just lecturing. And I really like coaching. It's the approach that I really prefer for helping students to improve. I like to work with students one-on-one and try to understand what it is that they are not getting so that I can then tweak it a little bit. And often, very tiny tweaks make really, major differences in how well they can succeed. So I sort of think of myself as a coach, and I think it's what I'm really good at. And so having found Junior Lab as a course to teach, I want to stay there.
Several years ago, our approach to teaching data analysis in Junior Lab was we would have a few lectures. We would take the first hour and a half of each lab session on the first couple of days of the semester and just lecture to the students. We'd give a Blackboard talk or a PowerPoint presentation and tell them everything there is to know that would get them at least through a semester or two of Junior Lab. Now, of course, nobody would remember any of that by the time it came to actually do data analysis sometime in the next few weeks after that. And given everything we know about how people learn, that is not at all surprising. So the way we do this now is there is a little bit of instruction either by some reading or a video on the web, which is mediated through the OpenEdX platform on MITx. They do a little bit of what amounts to a reading quiz on MITx. But that's when we don't necessarily believe that watching someone give a lecture on a computer screen is much better than giving a lecture in person, not necessarily. So we believe the real learning is going to happen the next day when they come to the classroom, and we're going to do some sort of very active exercise on this very same material which they just learned overnight. So the direct instruction that happens as part of the preparation, we really are treating it as the preparation. It's not the main learning. The main learning is going to happen with the active exercise that happens in class. But we just need to have some sort of priming so that when they arrive, they are ready to start that learning.
So one of the changes that we made over the last 3 or 4 years was to flip the classroom in 8.13 and 8.14. Essentially what we found is that we spend a lot of time in class with lectures by the lab staff, which in the end seemed to be only moderately useful in really getting the material across. So what we decided to do was to export the lectures in the form of videos to the MITx platform and replace the time that we spent on that previously with in-class exercises and class discussions to really rehearse some of the concepts that were introduced in the lectures in class, which also gives us a much closer communication with the students, and we can find out what it is that really needs to be explored in more depth.